We tend to think of the internet as this magical cloud, right? Something formless. But in reality, it's a physical world of wires and servers. And today, we're going to dive into a massive shift in how that world is actually built. A move away from these slow, centralized data centers to something way faster and a whole lot closer to you, the edge.
Okay, just picture this for a second. What if every website, every app, every piece of data was just there, instantly? No spinners, no loading bars, nothing. Sounds like sci-fi, I know, but it's the exact problem that some of the brightest minds are tackling right now.
And here's the thing. The solution isn't just about throwing bigger, faster servers at the problem. The real bottleneck, the final boss of internet lag, is literally the speed of light. It's the physical distance our data has to travel. So if we really want to build a faster internet, we have to crack the distance problem.
Okay, so that brings us to the heart of the matter, this problem of distance. Let's break down exactly why this physical gap is the ultimate speed limit for pretty much everything we do online.
Here's a great way to think about it. The old-school internet is kind of like a world-famous cafe, but there's only one, and it's in a single city center. If you live on the other side of the country, getting your coffee is going to be a slog, right? It's going to take forever. An edge network, though, that's like having a great local coffee shop on your corner. It's closer, so it's way faster. That's the whole idea. Move the internet stuff from one central city to thousands of local shops all over the globe.
So when you strip it all the way, this entire challenge really comes down to two big things. First, speed. How do we shrink the time it takes for data to get from a server to your screen? And second, safety. With all this data flying around, how do we keep it safe from the billions of threats that pop up every single day?
So, where do you even begin with a problem this big? Well, the first piece of the puzzle that companies started to tackle was the code itself. The big question was, how can you make an application's logic run everywhere at once?
Well, one of the first big answers came from platforms like Cloudflare Workers. It's a serverless idea that lets developers run their code across this huge global network instead of on just one server. It uses this amazing tech called V8 isolates. Yep, the same engine that powers your Chrome browser. And these things are insanely lightweight. They can spin up in under 5 milliseconds. That basically gets rid of cold starts, that annoying delay you sometimes get on a first request.
But, and this is a huge but, there's a catch. You can have your code running in a data center right next door to your user, which is awesome. But what happens if your data, all your user profiles, your product lists, is still stuck in a single database halfway across the planet? You've just solved one problem only to create a brand new bottleneck. The code is fast, but now it's just sitting there, waiting on the data.
And that right there, that sets up the great data challenge. How on earth do you make the data as fast and spread out as the code that needs to use it?
Okay, so the go-to approach here is something called asynchronous read replication. The idea is pretty simple. You have one main database where all the writing happens, and then you create a bunch of read-only copies, we call them replicas, in data centers all over the world. So when a user in Tokyo wants to read something, they hit the local Tokyo copy instead of the main one in Virginia, much faster. But this solution opens up a whole new can of worms, a really fascinating, kind of mind-bending problem. See, because those updates are asynchronous, the copies, well, they can fall behind the main database. Some might be just a few milliseconds behind, but others could be seconds behind. So what happens when a user's requests start bouncing between these different versions of reality? What happens when the copies are out of sync?
Okay, check this out, because this is where it gets wild. This is the time travel problem. Let's say replica A is super fast, only 100 milliseconds behind the main database. But replica B is slow. It's a full 2 seconds behind. So you post a comment and your request hits the fast replica A. Boom, you see your comment instantly. Perfect. But then you hit refresh just half a second later, and this time your request gets sent to the slow replica B. Well, since it's 2 seconds behind, it hasn't seen your new comment yet. From your perspective, your comment just disappeared. Poof, gone. The database literally just went backwards in time for you.
So how in the world do you solve that? It feels like you're fighting physics itself. Well, the solution is actually surprisingly elegant.
It all comes down to a concept called session-based consistency. It's an approach where developers can kind of wrap a user's chain of requests into a single logical session. And that session's job is to make absolutely sure that the user always sees a consistent, logical view of the data, even if their requests are bouncing between different replicas all over the planet.
Okay, so how does this actually work in practice? Think of it like getting a ticket at a deli. After your first query to the database, you get a consistency token back. It's your digital ticket. You then include that ticket with your next request. When that request hits a local replica, the replica basically looks at your ticket and goes, okay, this person has already seen the database up to this point in time. And if that replica isn't caught up to that point yet, it just waits for a moment until it is. Then it answers. It guarantees you never go backwards in time.
And what you get is, honestly, the best of both worlds. Compared to the old way of having just one slow, central database, this new approach gives you incredible performance because you're reading from a local copy. But it also maintains that critical data consistency, which prevents those bizarre time travel bugs. It just makes for a way better user experience.
All right, so this whole data solution is super clever, but it's really just one piece of a much bigger puzzle. Let's zoom back out for a second and see the full picture.
The core idea, the whole philosophy, is actually pretty simple. If you can move something from a central server and get it closer to the user, you should. And this isn't just about your code or your data. It's also a total game changer for security.
I mean, think about it. Why would you let a hacker's attack travel all the way across the globe to your main server before you stop it? Why not just block it at the very first data center it hits? Things like web application firewalls, DDoS protection, bot management, they can all run right at the edge, zapping threats milliseconds after they leave the source.
And the sheer scale of this new edge is, well, it's staggering. To make all this work, a company like Cloudflare has built out a network that's in over 330 cities worldwide. Over 330. It creates this incredible global fabric for the internet to run on.
And what does that massive footprint get you? This is wild. 95% of the entire internet-connected world is now within 50 milliseconds of one of these edge servers. That's faster than you can blink. That local coffee shop we talked about, it's now literally around the corner for almost everyone online.
And because this network is everywhere, it basically acts like a global immune system for the internet. It sees so much traffic that it can block, on average, 209 billion, with a B, cyber threats every single day. Just let that sink in for a second.
So what this all really points to is a completely new blueprint for the internet. It's an architecture that's built from the ground up to be fast and secure by default, just by moving all the smarts out to the edge.
So, I want to leave you with this thought. When the old limits of physical distance start to just melt away, when your code and your data can truly live everywhere at once, what new kinds of applications suddenly become possible? If the speed of light wasn't your enemy anymore, what amazing things would you go out and build?